Welcome to the P5 Masterclass videos. You're watching video number 4, P5 Backup. Ideally, watch these videos in sequence, starting with the installation and licensing video, followed by either number 2 or 3, depending on the type of target storage you wish to back up or archive to, followed by number 4 or 5, depending on whether it's a backup or an archive workflow you're wanting to set up. By watching 3 of these videos in sequence, you'll be able to install and set up a backup or archive workflow to your desired storage. You'll find more videos to explore in this series on Archiware's YouTube channel. Lots of detail in this video, combination of whiteboard explanations and physically going through the user interface of the product. These are the chapter markers that you'll find under the YouTube video, so you can easily skip to them. Let's start off by talking about what P5 Backup is for. So P5 Backup is for file level backup. That means it protects files and folders on your storage, and it does this by backing up and creating snapshots through time, which are effectively restore points from which you can restore the data as it was at that point in time. It's worth stating that P5 is not a bare metal recovery solution, so that means that it doesn't image disks that might contain operating systems so that you can recover those operating systems, and it doesn't integrate directly with hypervisor software such as Hyper-V or VMware to perform virtual machine image backups. Okay, so how does P5 Backup work? How it works is it takes your client file systems over here, which consists of folders that you want to back up or entire disks on your storage, whether that be Windows servers or NAS or SANs or whatever. So it takes the data from these file systems, and via the P5 Backup module here in the middle, we store your backup data either on LTO tape or on cloud or disk storage. So over here we have the storage pools that you've created, and we will back up to those storage pools, and in the process of doing that we have something called an index, which you can think of as like a database, which is tracking every file that you're backing up, whether that file ends up over here on LTO tape or in cloud or disk storage. That file is recorded in the backup index so that P5 can later recover that file. Now, the first time that you run your backup, all of the files that you have on the storage that you're backing up will be saved to the target storage over here. But then subsequently, when you run that backup again on the next day, what we'll do is compare the index and the file systems in order to see what we need to save in the next backup, and we're thereby saving only new or changed files. Now, since the backup is going to run at regular intervals, the index contains what we call snapshots of the contents of your storage over time. So each time the storage runs, maybe each day, we're tracking what is in those client file system folders, so you can go back and browse the snapshots and recover data as it was at a previous point in time. So this is the general structure of how P5 Backup works. You have your client file systems, you create a backup plan, you configure the target storage, and P5 creates and maintains an index that tracks what is being backed up over time in snapshots. And when you're setting up this backup workflow, those client systems on the left-hand side are P5 clients, and those are covered in the installation video. Then we have our P5 server in the middle orchestrating the backups, and on the right the LTO and cloud storage are configured via P5 pools, and there's a separate video in this series showing you how to configure those. Okay, so let's create a backup so it's clear how this all fits together. Here is my P5 web UI. I've logged in as an admin user so I can set stuff up. If we click to the backup module tab here, you can see a couple of things I've already done. I have obviously entered a license an evaluation license so the software can be used. And here under Clients on the left hand side, in addition to the local host, which is a data source where the P5 is running, I've installed P5 on a Linux host, and I've added that as a server client, so we can also back up data from this Linux host where P5 is running. The previous installation video runs through how to get that working. And then under Storage Manager, I've added a cloud service, which is a Wasabi bucket connection, and I've added a storage container for backup so that P5 can back up to that cloud service. We have two separate videos showing how to configure both LTO storage pools and cloud pools, which is shown here. We're using a cloud pool to back up in this video, but we could equally use an LTO pool. And so we now have a pool called Wasabi Backup that we can start backing up data to. Currently it's empty. So we're going to create our first backup plan. Under Backup Plans on the left hand side, click New at the bottom, and we can configure a backup plan. First of all, we need to remove the default name, and we'll call it Cloud Backup. And once we apply the name, then we have a backup plan that we can configure. At the top, we'll configure a backup task to back up some data from a client. And then at the bottom we'll configure a backup event which sets up when the backup will run and what storage it will write to. So for our backup task we'll click New. I'm going to back up some data from localhost, and this is the list of folders that this backup plan will back up on this client. I can either type paths in here or use the Browse button to locate the folder or folders I want to back up. So I've got a folder ready under my home directory in production share called Sample Backup Data. So I'm going to back up this folder with this backup. I could then browse and add other folders. I apply when I'm ready to continue. If I wanted to back up in addition files from my Linux server, I would be able to browse the Linux server just as in the same manner and choose files to back up from there and add those to a separate backup task. To keep things simple and quick, I'm just going to back up this sample backup data folder from my local machine. Down here under backup events, we'll create a new backup event. We can either run daily or on particular days of the week or particular days of the month. So I'd like to run it every day. 22-30 hours is fine. And importantly, the backup target storage, the Wasabi backup pool, has already been selected because that's the only pool that is in this configuration. So my backup event will back up to the Wasabi storage 10:30 every day. Apply that, apply the whole backup plan, and we now have something that we can run backup data and then restore from. So to run this immediately, I can click on the backup event, the Start Now button, so that yes, I do want to run it. And I don't want to limit the amount of data that the backup's going to save because I have unlimited storage in the cloud. So ignore this one, just click Start Now, and the Start Now button changes to the Job Monitor button, and I can click here to get to the Job Monitor. This is also something which is discussed in earlier videos. So you can see here my job is running. It's giving me statistics about how fast it's going, how long it's been running, and how much data has been saved. And because this is a cloud backup, you can see that there is a percentage of the current chunk of data, container that it's uploading to the cloud. So we'll let this job finish. You'll also notice that the backup job spawns an additional job which saves the backup indexes and P5's configuration to that cloud storage, which allows us to do a recovery of this P5 installation from that cloud bucket if needed. So whenever you run a backup, the backup runs an additional job to secure the P5 installation. So we can see now under finished jobs that our cloud backup completed successfully. That's what the green dot means. And it saved 900 megabytes. And we can double click on the job to see more detail. For example, it saved 262 files, and it also lists the container volume that the data was written to. So that took a couple of minutes, and this is essentially all that's required to start protecting your data. So I want to make that point quite strongly. Configuring the backup is very simple, and now this backup will continue to run. You can see at the top under scheduled jobs, our backup is going to run this evening at 22:30. Now if we want to see what was backed up by this job that just ran, we go back to the main window. Under the Restore tab, we click on Backup, and then you can see there is a backup index for each of the clients. So we have one for Linux, which we haven't used yet, and one for localhost, which will contain a browsable path down to the folder that we backed up, which was called Sample Backup Data. If we click in here, we can see the sample files that were backed up, and we can drill down into folders and see everything that's in there. At the top there's a breadcrumb trail which shows you where you currently are, so I could go back to the Sample Backup Data folder. If I double click on any one of these files, P5 shows me which container storage, or LTO tape if you're using tape, that this file is residing on, and when it was backed up, and the modification date of the file itself. You can see here there's a file called Invoice Bundle. If I want to do a search across the backup index, I can click on the search button and search for something. So let's search for invoice, and you can see there are several different invoice files in the backup. If I highlight one of these, at the bottom below the list of search results, P5 shows us which folder this invoice bundle file is actually in. So you can see this one is in this audio folder, and if I click down the list, you'll see these files were found in various different folders. If I clear the search results and go back to browsing, I can highlight some files and folders and click on Add to Restore selection at the bottom to set up a restore. So you can see the files that are highlighted are in here. I could, if I wanted to, browse and find other folders to add. So I can move around the index, select things I want to recover, build a list, and then hit Restore at the bottom. I won't restore yet because the other thing I want to be able to show you in this index is snapshots. So you can see currently we created a single snapshot today at 3 minutes past 12 because we ran one backup. If we run other backups and the data is changing between backups, P5 will be comparing that file system folder that we're backing up with the backup index, working out what the differences are, and creating a new snapshot by saving the changed or new files. So if I go back to my job monitor window, I can take the scheduled job. This is a different way of running manually. Highlight the job and click Start to run that job again right now. So what I'm going to do is, behind the scenes, I'm going to make some changes to the data that we're backing up, so there are some differences to save. So let me do that right now. Okay, that's done. So I'm going to start the job, and you'll see, as before, our backup sits in running jobs, and it will find some changed files and new files to back up. So let's let that complete. So you can see now we had the original job which saved 900 megabytes, and there's 140 megabytes of changes just saved. So I'm going to run this job 2 or 3 more times so that we have more snapshots in our index. So let's just wind forward. Okay, so over the past few minutes you can see down at the bottom of the job monitor window, I've run the same backup a few times, and on each occasion files have changed. So you can see how much data was saved by each of these runs of the backup plan, and then inside you can see how many files were added, how many were changed, and so on, and the reasons that the files were backed up. So now that we have several runs of our backup, obviously this would normally be on different days, we can go back to our backup index for localhost. Let's just close our restore palette, and if I drill down now to where that data is that we backed up, and we look in this menu, you can see that P5 allows us to browse what was in this folder at each of these points in time. So as I click to different snapshots in this list, you'll see things change. You'll see this team roster file at the bottom was there at 12:09, but it's not there in the latest backup. In fact, there's a completely different folder that was created. So it's therefore possible using this snapshot browser to go find files that may have been deleted subsequently and restore them, because P5 is tracking the contents of the folder through time so that you're able to restore data that might have been deleted. And even if you don't know where a file was located from the folder structure, the search results will expose deleted files and allow them to be restored. It's also possible to double click on a file, and if that file was modified, you'll be able to see the different occasions on which the file was backed up. So you can see here this file was backed up at 12:03, which was the first backup, but at 12:18 it was backed up again because it had just been modified. The file size also got slightly larger. So here's a file that changed and was captured in 2 different backups, and therefore the file will be restorable in the 12:18 or the 12:03 snapshot, and it will be a different version of the file. So this is the 12:03, you can see it's 7.4 megabytes, but if we go to 12:18, you can see that file is slightly larger. So when you're restoring, you're choosing files within snapshots to restore. So there are many versions potentially of the same file, and it's changing through time. Let's wrap up this section by actually restoring some files. So if I select some files here and add them to my restore selection, plus I think there were some additional files already in there, I can move around the index, choose what I want to recover, and then when I'm ready, I just simply hit the restore button at the bottom of this window. First thing I need to do is choose where I'd like to restore the data to. By default, we'll put these files back at their original locations. That may cause conflicts, and by conflict I mean it may mean that a file that already exists is being overwritten, in which case you have 4 options, from not doing anything to changing the name to overwriting or only overwriting newer files. Alternatively, you can choose to restore to a different client. So I could restore to the Linux server if I wanted to, and within a client I can choose a directory to restore to. So I can modify this directory by browsing and perhaps choosing a new folder that I'm going to create, like restored from backup. So let's choose that empty folder, and then I click the next button, at which point P5 will work out how many files it's going to restore, how big they are, and so on. And it will also tell us which volumes are required. With a cloud volume, there's a single volume that takes all the data, and with tape, we would be indicating here which tape or tapes are going to be needed to perform this restore. I'll hit the start button, and then we monitor the job. You can see there's a restore, and it's because this is a cloud restore, it's pulling containers down from that Wasabi cloud bucket, the container files that it needs to restore the files that we've asked it to restore. With container storage, it's downloaded in units of containers. So 1 or more containers will be downloaded, and then the files that we've requested will be put in the folder. The restore is finished. It's restored 260 megabytes, and here is the Finder window showing the restored from backup folder, and these are the files that we've just recovered from the backup. So that's how you restore from a backup in P5. At this point, we've really built a working backup solution, and everything from this point forward that I'll show you is going to be about deciding how long backup should be retained and how the storage media should be managed so that files that we're not choosing to retain forever don't need to be stored forever. Next, I want to talk about backup retention. So this is independent of the snapshots that are created in the index for data which is restorable. P5 needs to be configured so it knows how long to retain your backup data for. So the sequence of events goes like this. First of all, in a folder on storage that you're backing up, where there's a file that was backed up, you delete that file, so a source file is deleted. Now when you do that, you're expecting that you're going to be able to recover that file from the backup. So if you delete some data on a day that you don't mean to delete, and a couple of days later you realize, then it's fine because the backup has kept that data and you can restore it from the backup. But within the backup plan, we have something called a retention period. So you might set that retention period to 30 days or 90 days or 1 year, depending on what your requirement is for the backup. But when that retention period has expired, P5 will remove the file that was deleted from the backup. P5 will expire the file in the backup so that it can be then removed from the backup. So remember that this file that you backed up but then deleted is either on an LTO tape, or it's on some cloud storage or disk storage in a container. And so the file on the LTO tape or the cloud storage, it doesn't necessarily make sense to remove the file immediately when it expires, but ultimately that file can be removed from the storage. And when that happens, the file will no longer be in the index, and therefore it will no longer be a file that you can restore. So that's the general principle of retention. And what you have to do when working with retention is this bit here. So you have to decide what period of retention is sensible for your backup based on your needs from that backup. Obviously, the longer you retain deleted data for, then the more storage you'll need to hold the backup data, and that may be more difficult to provide depending on the amount of data that's changing and how much data you have to start with. Okay, so now let's look at the way that P5 backs up data to cloud and disk storage using containers. So if we take our source storage over here on the left hand side, let's imagine that we have a folder here that we're backing up and it has 100 files inside of it, and we're backing up to either disk or cloud storage. So inside the cloud bucket or the folder on disk, P5 is writing your data into files that we call containers, and these have several of your source files inside and are compressed, so they're not the same as the individual files that you are backing up. So the first time you run this backup, P5 backup is going to save all 100 files into some containers that are stored. So this is always the case when you first run a new backup. Everything is saved, and so let's say on day 1 this is called a full backup. It's called a full backup because everything is saved. So on day 2 we do something called an incremental backup. So let's say that some files have been added, so that we now have 110 files in here, and maybe some files have been deleted. So there are some small changes, and these are identified by comparing the source storage with the backup index, and then we save those changes in what we call an incremental backup on the second day. And then on day 3 we continue doing the same thing. We run these incremental backups which save the changes. So this can repeat forever, and P5 will manage the containers that it's storing on the cloud or disk storage, in the sense that if a lot of data is deleted from the source storage, then after that retention period has passed, we will identify the containers on the cloud and disk storage, and when they can, they will be removed. So where we have a container that contains only expired files, then we will remove that container from the cloud storage. And sometimes, in order to delete a container, some files may need to be saved again to a different, newer container in order for the older container to be deleted. And this is handled automatically as part of the backup task. And therefore your cloud storage bill, and talking specifically about cloud storage, will not be accommodating lots of deleted data. So P5 will look after this for you. And unlike LTO backup, which we're going to look at shortly, it's not necessary to run the full backup again after the first time that a full backup has run. So here we are back in our P5 admin interface, and if we go back into this cloud backup that we just configured, under the Options tab, so these are tabs are going across the top of the backup plan, you'll see the data expiration policy, and this, as it says, defines how long data written by this backup should be kept available for restoring, and the default is 28 days. So that means if you're backing up, as we are here, to cloud storage, and you don't change this number, then a file that you delete on the 1st of the month, by the end of the month you can expect that that file will no longer be available to be restored because it's expired, and the container that stored that file on the cloud storage will have been removed. When backing up to containers with P5 Backup, you can't choose when full and incremental backups run. The first backup will always be a full backup followed by incremental backups. So there's no configuration of full and incremental backups to do when you're backing up to containers, which are used for cloud and disk storage. So when you're backing up to LTO tape, most commonly you'll be sequencing incremental and full backups, and this is just a quick explanation of what that means. So on our whiteboard here, if we draw our source storage on the left hand side there, this is the storage that we're backing up, and then over on the right hand side we have our pool of tapes, so some number of LTO tapes there. And when we do our first backup, regardless of whether we schedule a full or an incremental backup, this is the first backup, so the backup will always be a full backup and will save all of the data. So if we have 1 terabyte of data in here, we'll write a terabyte of data to the pool of tapes. So that means the first tape will receive some data. The next backup, most likely you will schedule an incremental backup, and what that does is it compares the source data with the index that P5 is maintaining, and by doing that comparison we work out what we need to save, what's new, what's changed, and then we do this incremental backup, and that will save those changes, and that will be a small amount of data. And then generally you would just continue with an incremental backup each day. So each day we do this comparison, we work out what the differences are, and we write more data, and you'll gradually write these incremental backups, and they might start filling the second tape, and so on. So this is the absolute basics of doing backup to LTO. You begin with a full backup, you continue with incremental backups, and then at some point you'll choose when you want to do another full backup, and we'll discuss how you decide when that should be shortly. To illustrate this, I've created a second backup plan and a second pool. So here's an LTO backup pool, which is to be used for backup to tape, and I've created a second backup plan here called LTO Backup, that again is backing up a folder from my local machine. And down here where we're adding the backup events, if I edit this one, you'll see that when backing up to tape, you get the option to choose whether it's going to be a full or an incremental backup that you're scheduling. And you can see the note here that says when backing up to tape, it's recommended to perform a full backup regularly, as this increases data security and allows older media to be recycled. So we could have a full backup running every month on the first Friday, for example. So full backup runs on the first Friday of each month, and then I could create a second backup event to the same pool that's going to run an incremental backup every day, with the exception of the first Friday of the month, because on that day we're doing full backups. So a backup workflow, a simple one, might look like this, where there's a full backup taking place each month on a Friday, so that there's time for it to run over the weekend, and then every other day we're running incrementals. So this means that a new backup cycle will be created each month, and therefore once a couple of months have passed, the first backup cycle will contain data that maybe can be recycled, and those tapes can be reused based on the retention period, which we can set in the Options tab of the backup plan. So we could think of this as follows. We're running a full backup at the start of each month. So if we were to take a calendar that goes January, February, March, then we're running the full backup at the start of January, and then we're going to run incremental backups for the remainder of January, and so on. So full backup at the beginning of Feb, incremental backups followed by full backup and incremental backups. Now if you combine this with let's say a 30-day retention in the backup plan, this would mean that starting at the beginning of January, by the 1st of Feb, or the first week of February, any files that were deleted here at the beginning of January will potentially no longer be available to be restored, because we've set this 30-day retention, which means that the unit of removing data from the backups is a whole LTO tape. So if you imagine that we've got a set of LTO tapes over here on the right hand side, so these are our LTOs. We've got the first one, the second one and the third one. The unit of recycling is a whole tape. So that means that P5 will work out when the first tape can be recycled, because it doesn't contain any data that still needs to be retained. So if that first tape was filled, let's say, by this full backup over here, then by the time we get into the second backup cycle over here, this first tape can be marked as expired and can be then recycled and reused by subsequent backups that are running that need new tapes. So on our calendar here, we've got our separate backup cycles, which I'll delineate with the red line. So we have 3 backup cycles. So as the backup cycles fall outside of the retention of 30 days, the tapes used in those backup cycles can be recycled and reused. And the retention that you set in the backup plan determines when this can happen. One of the benefits of using LTO tapes to do backups is that the tapes themselves are transportable to different locations, so that you cannot have a single point of failure in terms of having all of your backup tapes at one location, and if something bad happens at that location, then you lose your backup and your live storage. Just in this graphic, what I'm wanting to illustrate is that you may have a set of tapes that you're backing up at your office, but one of the things that you can do with LTO tapes is that you can have 2 sets of tapes. So you could have one set of tapes at the office and another set at some second location, so that the data is then spread out over 2 different locations. And then what you might want to do is, on a daily basis, maybe you swap these around so that on any given day or any given week, you're writing to a different set of tapes and they're being swapped around. It may even be that you want to have 3 sets. So you've got one set that's on site where the tape hardware is to receive the latest backup. You've got one set in transit on its way to the office, and then you've got a 3rd set of tapes which is at this other second location. And there are even companies that will handle the movement of tape sets for you. So ultimately what this means is that you'll have a different set of tapes at the office location to receive the backup data on different days, and backup software needs to accommodate this through tape rotation to provide off-site protection. So that's what we're going to look at next in this section. P5 has a feature called alternating pools to accommodate this specific requirement. So the way it works is that you can have a single backup plan that can specify both pool A and pool B, and even pool C if you want to have 3 pools in the same backup plan. And what it does is it figures out which pool it has available based on the tape that's mounted if it's a single drive, or the available tapes in a tape library. So let's say on a given day, if it finds that it has pool A tapes available, then the backup plan will write to the pool A tapes. And if it's doing an incremental backup, it will take into account how long it's been since those tapes were written to save additional days worth of changes. So normally with an incremental backup, if it's running every day, then it's going to save all the changes since the previous day to the pool that it's writing to. But if you imagine that the second pool B is introduced maybe after 1 week, and therefore that pool has not been written for 7 days, then the backup plan will write as part of the incremental backup, the last 7 days worth of changes will be written to pool B, so that if pool A is not available and pool B needs to be used to restore from, all of the files will be available in pool B, and you'll be able to restore everything back to your live storage from that pool and nothing will be missing. So this feature is called alternating pools, and it allows a single backup plan to specify pools A and B and even C if that's how you want to configure it. So up to 3 pools can be configured. Let's see how that works. So to illustrate this, I have created 3 tape pools A, B and C called LTO Backup A, B and C. And then if we go into our backup plan and edit the existing backup plan, for each backup event, you'll notice that where the previous pool was selected, there is a plus button that allows up to 3 alternate pools to be selected. So in here I could choose pools A, B and C in that order for this backup event. And that means that when this backup event runs on the first Friday of each month at 22:30 hours, it does a full backup. It first looks to see if it has an LTO Backup A tape available to it by looking at the inventory of a tape library to see if there are any tapes available that it can write to in that pool, or with a single drive seeing if a tape from that pool is mounted. If there aren't any tapes that it can write, then it will go down to the next alternate pool in the list and so on until it reaches C. So in order for the backup to write to the B pool, one must ensure that there are no A tapes available for it to write. The tooltip here clarifies this situation. It says the feature allows up to 3 pools to be alternated to achieve on-site, off-site tape storage. P5 will use the first pool that has available volumes, checking in order of the way that they're listed, and when performing incremental backups, all data will be added to the pool since it was last used, as I was just explaining. So you can use this for both the full and the incremental backups to have the ability to switch out pools of tapes so that you can have a rotation of your tape pools going off-site, so that you have the added protection of separate sets of tapes being written independently. The final LTO backup technique that I'm going to mention in this video is that if we go back into our backup plan here, it is possible to enable progressive backup for a tape backup, and you do that by going into advanced options and ticking the progressive strategy box here. Now what this does is explained here in the paragraph above, and if at all possible I would recommend that you schedule full backups to allow recycling of older tapes in a backup. But if for any reason this isn't going to be possible, you can do progressive backups with LTO. What happens is the retention period that's defined here is used to determine when an entire tape is ready to be expired, and when that date is reached, P5 will save additional data as part of incremental backups, resaving files that were on the tape to allow that tape to be recycled. So this means that rather than scheduling full backups and those backups running at times that you've coordinated and know that there's enough time for them to complete, with progressive backup enabled, the incremental backups will get much bigger in order to resave the contents of older tapes to allow tapes to be recycled. So this means that you need to be prepared for incremental backups that are going to run for a long period of time. You can limit how long they're going to run for here after you've enabled progressive strategy, and then you're going to schedule an incremental backup event to a pool or pools to run at a particular time every day, and then P5 will run on this kind of never-ending backup where it's just saving changes but also saving additional data to allow expired tapes to be recycled. So let's wrap up with this table I've drawn with key takeaways about P5 Backup. So starting off, creating a backup is simple. What you need to begin with are storage pools, which may either be consisting of LTO tapes or cloud or disk storage. Once you've got your storage pools, you configure any clients to capture data from hosts other than the one P5 is running on. And then you need the directories that you want to back up on those clients. So you start with your destination storage as your pools, then you've got your clients where you're going to back data up from, and then finally you need a schedule that defines when the backup's going to run and exactly how it's going to run. With that done, we need to think about retention. Retention determines how long deleted files are going to remain recoverable. So that how long is a decision you need to make, and then you need to plumb in a value in days for your retention period so that you know you'll be able to restore data that was deleted, let's say 28 days ago. When you're backing up to cloud or disk storage, you'll use the automated progressive backup technique, which will handle the recycling of older containers holding your data on that cloud or disk storage. For tape environments, you need to think about sets of tapes, which in our language is pools. So if you want to have multiple sets of tapes for various reasons, then you need to create pools and label tapes into those pools. That might include having provision for on and off-site pools of tapes where tapes are rotating on-site and off-site, so additional pools will need to be created. And then you'll schedule your full and incremental backups to write to those tapes or across those pool of tapes in a way where you can accommodate those full backups that are going to save all your data back to tape so that you can recycle older tapes. Or as we've just discussed, there is always the option of progressive backup, which will remove the need to take and schedule full backups deliberately, but will introduce the saving of large amounts of data to allow tapes to be recycled. So we'll end there. Thanks for watching this video.